Okay, here are our 2.6 notes. We're looking at operations and composition. All right, so there's several concepts in here. However, the concepts that are in here, some of them are obvious that we've done before, so we're going to skirt through those, and some of them I want to spend a little bit of time on. So for the first one, it's the operations on functions. So just that basic. If I have f plus g of x, if I show that f plus g, I'm just taking these two functions and adding them together, right? Same thing if it's f minus g, you're just subtracting. If it's f right next to g for multiplication, then you're just multiplying those. And then if it's f over g, then you're dividing that. So really it's just saying here, instead of just having values that you're looking at, you're just talking about them in terms of functions. So these functions are add, subtract, multiply, and divide. Now, when you divide, keep in mind, you can't have a 0 in the denominator, right? So that's all well and good as long as 0 is not just in the denominator. Okay, so let's try some of these on. Add, subtract, multiply, divide. Here's example 1. We're going to let f of x equal x squared plus 1 and g of x, whoops daisy, g of x equal 3x plus 5. Then I'm going to perform these operations. So my first one is going to be f plus g of 1. So I'm going to add these two functions together. Where I have an x, we're going to put 1 in there, right? That's my input value whenever I add these functions. So I have this x squared plus 1. So wait, I'm going to put this up above here. So with my f of x, I'm going to scoot this down, actually, and we're going to talk about it like this. So if I have f plus g of x, this would be f of x plus g of x, right? Scoot that up just a tad. And then I have this f plus g of x, so this would end up being x squared plus 1 plus 3x plus 5. Then you have your like terms that you can put together. Everywhere you see an x, that's where you're going to put that 1. So let's put this together. We have 1 squared plus 3 times 1 plus 6. And that 6 comes from that 5 plus 1. Then you just simplify. 1 plus 3 plus 6. So f plus g of 1 is equal to 10. All right. If it is helpful to write this out, then you're welcome to do that. If not, it's no big deal. You're just plugging a 1 in place of that. You could have plugged a 1 and the x's up here whenever you wrote that out and then simplified it. That's all your prerogative. Pardon me. So however you want to do that, that's fine. So with addition, that makes an impact. Now, whenever you do subtraction, so if I do f minus g of negative 3, my f of x function, so if I plug in a negative 3 squared plus 1, because this is my f of x function, right? I am subtracting that off my g of x function. Remember what we said? 98% of success in mathematics is organization. When you are subtracting, you need to use your grouping symbols. That doesn't look like the word grouping at all. You need to use grouping symbols to show that I'm subtracting that whole thing off. So you're subtracting off that whole amount of that 3 times x plus 5, and I'm plugging in a negative 3. So just pay attention to that. Your grouping symbols make an impact. So I now have negative 3 squared is a positive 9, because negative 3 times negative 3, minus, Here I end up with 3 times negative 3 is negative 9 plus 5. So 9 plus 1 is 10 minus that negative 4. Whenever you subtract a negative, you add the opposite. So my value here of f minus g of negative 3 is actually 14. So you're just plugging values in, right? That's the whole moral of the story. If I'm just going through here, then I'm just plugging in these values, and then we come up with what it is there. Okay. So let's use the same ones here. F of x is equal to this x squared plus 1. G of x is equal to a 3x plus 5. If we do part C, this is f times g of 5. So just plug it in and multiply. So I'm just going to plug all of these in at the same time. We end up with 5 squared plus 1 times 3 times 5 plus 5. Then I expect you to be able to do a lot of this in your head. 26 times 15 plus 5 is 20. So 26 times 20 would be what? 52. And put that 0 on the end for 520. Remember, we're back to that same thing where you don't get a calculator in calculus, so the more mental math you can prep yourself and work with, the better off that'll be. You always check yourself with your calculator. So that's cool. Let's do a division, just so we can try them all out. So my f of x function will end up being 0 squared plus 1 over 3 times 0 plus 5. Now, just because I'm subbing in a 0 does not put a 0 in the denominator. I actually have a 5 in the denominator, right? So 0 plus 1 is 1, and 0 plus 5 is 5. So my answer is 1/5. I can plug in zeros, that's no big deal. But you just have to make sure that there's no 0 in that denominator. Okay. Cool. Let's try this one on. So we can plug numbers in, but we can also go generic on this, right? Example 2, we want to let f of x equal 8x minus 9 and g of x equal the square root of 2x minus 1 and perform those operations. So we're going to add, subtract, multiply, and divide. We're going to do all of them. And then, once we get finished with that, we're going to come up with the domains. So my first thing we're going to do is f plus g of x. So I'm going to add these together. Here I have 8x minus 9 plus the square root of 2x minus 1. There are no like terms. There is nothing else you can do with that. So you are finished. Part B, when I subtract. We have 8x minus 9 minus the square root of 2x minus 1. There are no like terms. There is nothing else we can do with that. So you leave it. If I multiply these together, I have 8x minus 9 times the square root of 2x minus 1. There is nothing else we can do. Does it feel like a broken record? There are no like terms. There is nothing else we can do. The real thing here is we want to talk about domain. So even if I have f divided by g of x, then I end up with 8x minus 9 over the square root of 2x minus 1. I'm not going to rationalize this denominator. We're just going to leave it down in the denominator. It'll be fine. It's not going to hurt anything down there. So just leave that. Now, the real thing that we want to do here is figure out what the domain is. When I'm looking at these problems, my f of x function here, my domain for my f of x function is going to be infinite. It's a line, right? So there's nothing that's going to be crazy on that. It's simply just a line. So whenever I'm going through and I'm trying to figure out what my line is, it's just infinity. Then I come over to the radical. Now we know you cannot have a negative underneath that radical, right? So because I can't have a negative under the radical, I want to say, where is 2x minus 1 going to be greater than 0? Greater than or equal to, because it could be equal to, right? So solve for that. add 1 to both sides, divide by 2. My domain for g of x are all the values of x that are greater than or equal to 1/2. In my head, I had 1/2, but I wrote down a 1. It's actually 1/2. All the values that are greater than or equal to 1/2. And then those are the values that we're looking at. All right? Okay. So when you go to find these domains, once we get the domains of each one of them, then that makes a difference. You're looking for where they intersect or where they cross over. The beauty of this is the fact that my very first domain is infinite. So I don't have any things going on there. But on my second domain, I have restrictions. So where I have restrictions, I want to say where they intersect. So because this one's infinite, it doesn't matter. This one intersects and only does a certain part of infinity. So therefore, the domain is going to be from 1/2 to infinity, because it's all the x values that are greater than or equal to 1/2. So we use that bracket again because it's an or equal to. And then your domain here will be the same. Here will be the same. Now what about this? Because it's all where they intersect, right? What about this part D? What's going to be different about part D here? This is going to be a parenthesis. And the reason why it's a parenthesis is because it can't be 1/2, because 1/2 is what makes that 0. That's what we figured out up here. What makes this 0 is that 1/2. So it's up to 1/2, but I can't have that 0 in the denominator, so it's not included. The biggest thing that you want to look at whenever you're looking at your domain is where do they intersect? And that's what you want to know. All right? All right. Very cool.